This is the type of problem that we're going to be dealing with today. We're going to basically be mixing problems that we did yesterday with problems where we now are going to actually have a number multiplied out front of the x squared. So we're going to be learning how to deal with that along the way as we go here. Now, to see how this first graph will look, and yes, you'll just graph this one along with me, we're going to start by kind of looking at it from the original perspective about how we graphed any function for the first time, or bring it back to the table of values that we would make. Now, in this case, you notice I have my original x's here, and then the x squared here. Now, that's what I would normally graph. So, like, normally I go over 2 and up 4, and all that kind of stuff. And yes, you're still going to need to know that pattern. But in this case, it's not just x squared, it's going to be 2x squared. And so I need to take each of those x squared values, and I need to double them. It's like 2 times 0 would be 0. But 1 times 2 would be 2, 4 times 2 would be 8, 9 times 2 would be 18. We're always just doubling whatever those values are. And that tells us what our new vertical increase should be. So, for instance here, my first point should be at 0, 0. Okay? Nothing changed there. Why? Because there's nothing added or subtracted in this particular equation. And so, there is no shift. All right, next up, instead of over 1 up 1, I'm going to go over 1 and up 2. So we go over 1 and up 2. And then instead of over 2 and up 4, we're going to go over 2 and up 8. So over 2 and go up 8 from there. Now from there I would go over 3 and up 18, except it doesn't fit on my graphing grid, so I don't need to worry about that point. But I do need to go on the left-hand side as well, which of course is still going to be doubling my normal height, and they're going the same heights as what I would normally see on the right side. So draw those points in, and then draw the curve that goes through them. All right, and then we need to describe the transformations. So we got one transformation here, the multiplying by 2. We want to see what that did. Well, let's take an example point. Instead of the over 2 up 4, notice that point is now up here. It's now over 2 and up 8. What we're doing is we're doubling the heights of each of these points. That's what that 2 is doing. Now notice the width didn't change. It only doubled the height. So then when we actually go describe this transformation, it will be a vertical, and if I multiply it, then it's stretching it. So it is a vertical stretch by a factor of 2 when we go to describe this transformation. Yes, it's good to make note of that. So then having done that, you now have everything you might need in order to be able to do a problem that's a little bit more complicated. You have all the tools you need. Go ahead and write this equation down above your next graphing grid. And then the first thing we're going to do is we're going to find where the vertex is. And so the first thing we need to find when finding the vertex is the x. So we're going to go x equals negative b over 2a. And we're just plugging into that. Okay, so x is going to equal a negative. The value of b here is the negative 24. Because remember, a is whatever's in front of x squared, b is in front of x, and c is the constant at the end. And so my b value is negative 24 on the top. And that's going to be over 2 times the a value, which is 3. All right, now we just need to calculate out what this value will actually give us. And you're actually better off not even using your calculator here. So let's actually see why that would be here. So the negative is still the negative, and I'm going to do negative 24 divided by 2 times 3. Notice I got to do the 2 times 3 first. So 2 times 3, of course, is 6. Okay, so what's negative 24 divided by 6? Yeah, negative 4. And so if I have a negative 4, then that means x equals 4 here. It was easy to do without the calculator, right? But what I see happen is some people will insist on using a calculator, and what they type in is negative 24 divide by 2 times 3, and it gives them an answer of 36, not 4. Why is that? The calculator is doing what you told it to, but what's it doing that we don't want it to do? Yep. It is first doing that division, and then it's taking that number and multiplying it by the 3. That's not what we want to have happen. If you're going to insist on trying to use the calculator for this and typing it in all at once, you'd have to put parentheses around that denominator in order for that to come out right. But as I said, pretty much all these you can do without the calculator, and if you can't do it without it, just skip it because you don't need it there. All right, now that we found the x-coordinate, I need to find the y-coordinate. How do we find the y-coordinate? Yep, plug it in. So take that 4 that we just found and plug it in for x in the original equation. All right, now we have our vertex. We know our vertex then is at 4, -8. All right, and now that I know that, before I go ahead and make the graph, I do want to write this in vertex form. So we're going to go y equals, and remember the very first thing I put in that vertex form is the a value. Okay, what's the a value in this problem? 3, yep. So we go 3, and then we do our parentheses. Then it's x minus the x-coordinate of our vertex. In this case, that is 4. So it's going to be x minus 4. Remember to square your parentheses. And then it's plus the y-coordinate of our vertex, which is -8. But we don't really want to leave it as plus the -8. We can clean that up a little bit. So instead, just write it as -8. Now that is our vertex form, and that's what we're going to use for graphing. And you'll also notice why I actually have you write it in vertex form here. Because if all we did was figure out where the vertex was and then start graphing, we could very easily forget about the 3 here. And we have to be able to see that 3 there and see that that's also going to be stretching it as we go. So let's go make our graph. The very first point we plot, of course, is the vertex. So we're going to go over 4, and we're going to go down 8 and plot our first point there. Now into the stuff that's a little bit newer today. We're now going to be applying the 3. So instead of going over 1 and up 1, I'm going to go over 1 and up how far? 3, exactly. So over 1 and up 3, and we're going to go ahead and do that on both sides. All right, from there, instead of over 2 and up 4, I'm going to go over 2 and up how far? Yep. I'm going to be doing 4 times the 3. So it is 12. So we go over 2 and all the way up 12. All right. It's possible that we can fit another point on. Let's actually check it. Normally, I'd go over 3 and then I'd go up 9. What's 9 times 3? 27. Can I go up 27 on this graph? No, I can't. And so then I can go ahead and draw the graph that goes through it. And we are done. And so for this problem, it's going to be just like we did with the 2x squared, except it's a 1/2 x squared now. So we just need to see what happens when it's a 1/2 instead of a whole number. Well, it's going to basically be doing the same kind of thing. It's going to operate the same basic way. So is there any addition or subtraction in this equation? No. That means that our first point, our vertex, is still at 0, 0. So plot your first point there at 0, 0. And then we're just saying whatever I normally go up, I'm still going to multiply it by the number out front. Just in this case, I'm multiplying it by 1/2. All right, so instead of over 1, up 1, that means I'm going to go over 1 and up 1/2. And yes, we're going to do that on both sides, right? And then, instead of over 2 and up 4, I'm still going to go over 2, because notice this doesn't change how far we go over, but only how far we go up. So instead of going up 4, we're going to go up 2, because we're going up 1/2 as far. And so, go over 2 and up 2. Next up, we're going to go over 3. Normally, I go up 9, because 3 squared is 9. What's 1/2 of 9? 4.5 or 4.5. Yep, same idea. And so go over 3 and up 4.5. Because normally it's 3 squared is 9, and 1/2 of 9 is 4.5. Looks like I'm going to be able to fit more on there, though. So let's keep going. What's 4 squared? 16. And 1/2 of 16 is 8, which means I go over 4 and up 8 instead of 16. All right, we haven't had to go over 5. Let's go over 5. If I go over 5, how far up should I have to go? Normally. 25. Yep, because it's 5 squared. What's half of 25? Yep, 12.5. That does not fit on our grid, so we can go ahead and draw the curve through the points that did. And you actually get a really good sense of the curve when dealing with one of these. Since it kind of squishes it down, we can see that. And notice I do want us to be able to describe this transformation. And when we multiplied it by 2, that was a vertical stretch. But it wouldn't make much sense to look at this as a vertical stretch here, because like the point that used to be up at 4, it's now down at 2. It's not being stretched, it's being squished, because stretch insinuates that something's getting bigger. In this case, we need a way to talk about it actually being smaller. And, you know, for some reason, a vertical squish by a factor of a half just doesn't sound technical enough. So, how else could we describe something that's being squished down? Well, we can describe it as being compressed. So this would be described as a vertical compression by a factor of 1/2. Now, as you might guess, based on the problems we've done so far, or just having spent enough time with me, you know that I'm about to give you another problem to graph, where I'm going to give you a fraction in front of the x squared, but there's also going to be like an x term and a number after that as well, right? And when we graph from that sort of form, that standard form, the very first thing we have to do is we have to find the vertex. Now, that fraction can sometimes make the math a little bit trickier in there, so I want to give us a little bit of practice on that. So we're going to just find the vertex for this equation. You don't have to graph this. We're just going to find the vertex. So do this on whatever paper you have handy. Write down the equation first, and then I'm going to walk you through this first one before you practice one on your own like it. All right, so if we're going to find the vertex, we start the exact same way that we always do start for finding the vertex, which is the negative b over 2a. If you don't yet have that memorized, you probably will soon, because notice it keeps coming up a lot. All right, so then, in this case, that's going to be a negative 6 over 2 times 1/3. Yes, we have a fraction within our fraction, and that's going to be okay. This will provide us with an opportunity, though, to remind ourselves about how we do some fraction operations. So the very first thing we're going to do is just simplify the denominator of my fraction, which means I need to do the 2 times the 1/3 here. Well, if you don't remember how to do the multiplying by the fraction, let's remind ourselves the long way. I would start by turning the 2 into 2 over 1 because I want them both to be fractions, and any whole number, if I want to write as a fraction, I write it over 1. And then to multiply fractions, we multiply straight across the top and straight across the bottom. So on the top, I'm going to do 2 times 1, which is 2. And multiply across the bottom, that's 1 times 3, which is 3. And so this is going to be negative 6 over 2/3. All right, so having done that, I now, when I hit my next step, I'm going to have to do that negative 6 divided by 2/3. So let's do that one over on the side as well. So if I'm going to do negative 6 divided by 2/3, I have to remember how to divide by the fraction. And of course, just like the last one, I do want them both to be fractions. So if you're a little rusty on this, here's your refresher. And then this is the one where we flip and multiply. Or if we want to say it more the technical way, we are going to multiply by the reciprocal. What that means in practice is that our first fraction stays the same, so that's still negative 6 over 1. But our division changes to multiplication, and at the same time that I change the division into multiplication, I flip the fraction upside down, which is why we say that we multiply by the reciprocal, because the reciprocal just means flip the fraction upside down. Now that it's a multiplication problem, we just multiply straight across the top, negative 18, and straight across the bottom again, and negative 18 over 2 is negative 9. And so I end up with a negative 9, or in other words, x just equals 9. And you got your x coordinate. All right, once you have your x, we still need to find the y. Let's practice our order of operations with that. Please go ahead and plug that x value back in and find out what y would equal there. All right, so we plug back in, we find our y value, and we have our point. And in this problem, all we need to do is find the vertex, so we don't need to go further. We don't need to go into the vertex form. We're done. It's just an answer of 9, -7. All right, so we did this one kind of together a little bit more, where I walked you through especially finding the x value. I'd like you to now find the x value on your own of one of these. This one, it basically operates the exact same way, just some different numbers in there. So go ahead and write down this one and then find the location of the vertex again. So the first thing you're doing is you're working through and you're finding out what that x is going to equal. We're not totally done with this one yet, but you can see here how we're doing the 2 times the 5 fourths. I went ahead and reduced my 10 fourths to be 5 halves, just because I find that to be a little bit easier. But if you do the work plugging in the 10 fourths, you'll still end up with the same final answer. And then this is what we actually get for our x value. We get the -4. And again, the work shown there on how we did the 10 divided by the 5 halves, in case you're a little bit rusty on that piece as well. Now that you got your x, find your y coordinate. All right, when all is said and done, you should then end up with the coordinates of -4 and -3 for your vertex. All right, so now that we've found the vertices with the fractions in there, now it's time to do one and then actually make the graph. So I'd like you to graph this by first finding the location of the vertex, write your vertex form, and then make your graph. All right, so we get our vertex at 3, 0. I then need to write my equation in vertex form. So we go y equals a comes first. Our a value here is 1/3. Then I start the parentheses. It's going to be x minus the x coordinate of my vertex. In this case, that is 3. So it's going to be x minus 3 squared. And then plus v, but v here, the y coordinate of my vertex is just 0. I don't need to write plus 0. I can just leave it like that. And so now I have my vertex form, and now that you have your vertex form, you can make your graph. So plot those points from there. All right, now let's go ahead and make that graph, plotting our points. So my first point is my vertex, that's over at 3, 0. Because notice I'm going right 3, and I'm not going up at all. But then from there, sometimes the 1/3 can feel weird. It's a little bit more clunky than like a 1/2 is, but we still use it the same way. It just might feel a little bit clunkier though. All right, so instead of over 1, up 1, we're going to go over 1 and up 1/3. Because we're going up 1/3 as far. And then, instead of over 2 and up 4, I have to go up 1/3 as far. 1/3 of 4 is 4/3. A nice easy way to know it, right? 4/3. Which, probably a little easier to think about it, is 1 1/3. So I'm going to go over 2 and I'm going to go up 1 and 1/3. Right, next up, I got to go over 3. When I go over 3, I normally go up 9. What's 1/3 of 9? Well, that would be 9 divided by 3, which is 3. And then over 4. Well, that's normally up 16. 16 divided by 3 is 16/3. 16/3 is 5 1/3. So go over 4 and up 5 1/3. Like I said, the thirds can be a little bit more clunky. You know, it feels a little bit weirder having to go to 1/3, but it's still the same process, right? All right, so then next up, we're going to be going over 5. If I go over 5, normally I'd go up 25. So in this case, I'll be going up 25/3. 25/3 is 8 1/3. So go over 5 and up 8 1/3. After that, we'd be going over 6. 6 squared is 36. So normally it's over 6 and up 36. 1/3 of 36 then is 12, which kind of fits on my group. Probably doesn't fit on yours. If it does, go ahead and plot it. But otherwise, go ahead and now draw the curve that goes to those points that you plotted. And this graph is done.